And we may not wind up doing all of them, but we're going to see. Because like I said, I want you guys to understand it. That's the whole point, okay? Okay. So part of what you've got to do is you have to be able to take information that's given to you and draw conclusions that are real. We're not just making crap up, but draw conclusions based on that information. Okay, so let's start with let's make our little T-chart here. And I'm going to make it big. All right, so let's start with the very first thing they tell us. They tell us C is a midpoint of BD. We're going to write that down because they gave it to us. So C is a midpoint of BD. How do we know that? It's given. Now tell me what midpoint means. What does that mean, midpoint? It's the point in the middle, right dead in the middle, right? So if you have a point that's right in the middle of a segment, what does that do to that segment? You got to, it cuts it equally in half, doesn't it? So this point right here, that point, takes this segment right here, BD, and it makes this segment and this segment congruent to each other. Do y'all see what I'm talking about? So we would say, our next statement would be, oh, you know what? Since we know C is the midpoint, then that means that BC is congruent to CD. Now, how do we know that? Definition of a midpoint. Because we know what a midpoint is. So if we have a midpoint, we know that it makes two congruent segments. Okay? All right, so let's look at the next piece of information they gave us. They said AB is perpendicular to BD. Now, how do we know that? Given, right? They gave us that. Now, what does that mean, perpendicular? What does perpendicular mean? I hear some, yeah, what does that mean?
Isn't that like no, that's not. It's not.
No, it's not area.
It's like lines, right?
It is lines, Let's see what Jocelyn thinks back there. Jocelyn, what do you think? They intersect, but they're at a very special way. What does perpendicular mean? They intersect in a very special way. At a right angle. Perpendicular lines intersect at 90 degrees. So if I know that this line and this line intersect at 90 degrees, what does that tell me? What's a right angle? Angle B, right? That tells me angle B is a right angle. So my next statement is angle B is a right angle. Or I could also say, I'm going to write it out here. I could also say angle B, that's not a B, angle B equals 90 degrees. And I could write it either way. Okay? Either way is fine. Now, how do I know that? What's my reason behind knowing that? What statement did they tell us? They told us these are perpendicular, right? So our reason behind knowing this is definition of perpendicular lines. That's how we know it. All right? Now, what's the next statement they said? They said, oh yeah, you know what? BD is perpendicular to DE. So here's DE, right? Here's BD, right? I need to write given over here. So what does that tell us about those two? That's a right angle. So our next statement is, oh, so that means angle D is equal to 90 degrees, or angle D is a right angle, right? Either one of those is fine. How do we know that? Same reason. Definition of perpendicular lines. And you can abbreviate. I'm writing it all out so nobody is confused about what I'm writing. But you can abbreviate and that's fine. Now, if those two angles, if angle B is 90 degrees and angle D is 90 degrees, what conclusion can you draw about their relationship to each other? They're congruent. And I know this seems really silly, but we need to say that. We need to say, oh, so that means angle B is congruent to angle D. And so we could say that. Good morning, Aubrey.
You can fix everything.
Oh, you're sweet. And Victoria is sweet because she was going to get up. Y'all both sweet. Aubrey's going to move things around. You okay this morning? Okay. Okay. Angle B is congruent to angle D. Now, how do we know they're congruent? Well, they're both right angles, right? So we could say definition of right angles. Okay, so that's our reasoning. Definition of right angles. Okay, so here's what we've got so far. We know that this angle here is congruent to this angle over here, right? We know that this side right here is congruent to this side right there. That's okay. That is so fine. Yeah, I am running out of space because I wrote kind of big, but I only have two more statements to make, and then we'll be done here. Okay, we only have two more statements, so everybody knows. Okay. Now remember, we need one more piece. We need one more piece. We either need to know. Well, we actually would knowing another side is congruent get this for us. It would if and only if it was BA and ED. Okay? Because then that would be side, angle, side. Y'all see what I'm saying? And that would be side, angle, side. Unfortunately, we have no knowledge about those two. They didn't tell us nothing about them to each other. Right? Do we know anything about any of the angles on there? What angle do we know information about that we haven't already talked about? Those vertical angles. BCD and DCE. Right? So BCA, my bad. Angle BCA is congruent to angle DCE. For what reason? Vertical angles. And you could write definition of vertical angles. I've just always wrote vertical angles. Technically, I think the phrase definition of vertical angles is more correct, but if you just put vertical angles, you're good. Okay? Now that we know this angle is congruent to this angle, and this side is congruent to this side, and this angle is congruent to this angle, what do we know about these two triangles? We know they're congruent. So our last statement is that triangle congruence statement. And we say triangle ABC is congruent to triangle EDC. Now I wrote it exactly the way they asked me to, right? And what is my reason for that? Which triangle congruence theorem am I using? Angle, side, angle. Y'all with me? Does that make sense? Okay. And this one was, I agree with you, this one was a little bit long, right? It was a little bit long. And that's because they didn't just come right out and tell us some of it. They didn't come right out and say this is congruent to this. They gave us information that we had to draw conclusions about, right? Okay, so let's do the next one together. Huh? All right, so let's make us a T-chart. Okay, what's that first piece of information they said? BA is congruent to ED. How do we know it? It's given. BA is congruent to ED. Now, this is a side that's congruent to a side, right? Okay, what else did they give us? Okay, so they said C is midpoint of, and they told us this is one statement, right? Of BE and AD. And that's given. Okay, so let's talk about what that means to us. So C is the midpoint of BE, and midpoint means that it's right smack dab in the middle. What does that create? Two equal segments. Which two segments are equal? So BC is congruent to CE. This one is congruent to this one, right? And AC is congruent to CD, right? This one is congruent to this one. Now, how do we know both of these things? What's our reason behind both of those? Definition of a midpoint. And we're going to make life a little easier and just write it one time for both of them. Okay? We'll put the word and between them. We'll make that one statement. So this is a side is congruent to a side. This is a side is congruent to a side. This is a side is congruent to a side. So what conclusion can we draw based on that information? And what's our reason? Y'all seeing how that works? Is that making a little more sense, maybe? Okay. Do y'all want to try the two on the back on your own? No? That's all right. This is, like I said, this is important that y'all understand this. So if we have to do all four of these together, that's fine. You good? You kind of get it now? Good job. All right, let's go ahead and look at those two on the back together, all right? And I'll give you some different problems as you show me you know how to do it. All right, so let's make our little T-chart. Okay, so they told us that BC is congruent to DA. They said it. So it's given. BC is congruent to DA. What else did they tell us? AC bisects angle BCD. They gave us that too, right? Now, what does it mean? The word bisect. What does that mean? Cuts it into two equal pieces. So if AC, this is this guy right here, if it bisects BCD, then what does that mean about this angle and this angle? They're congruent. So now we make that statement. We say, oh, well then that means that BCA, right? Angle BCA is congruent to angle DCA. And what's our reason behind knowing that? Like, how do we know it? Definition of a bisector. We know what a bisector is. So since we know what a bisector is, that tells us that those two angles are congruent. So this is definition of a bisector. Right? So we know that these two sides are congruent because they told us. We know that these two angles are congruent because we figured that out. Right? What else do we know? Because that's all the information they gave us. So, since they share this one, that means that AC is congruent to AC. Because they both have it. Right? So, since they both have it, our reason is reflexive property. That's our reason. So that's another side. So we know this side is congruent to this side. This angle is congruent to this angle. This side is congruent to itself. Right? So that means we have a side, an angle, and a side in that order. So what does that tell us about the two triangles? They're congruent. So triangle ABC is congruent to triangle CDA based on side, angle, side. We good? We good so far? Is it making a little more sense to you now? How you take the information they gave you and apply that knowledge? Right? Okay, so let's go ahead and talk about this one. All right? Okay, so what did they give us? They said what? Okay. Given. Now, and they're already marked on the diagram, right? Now, what do we know because they told us they're right angles? What information does that give us? First of all, what does right angles mean? They're 90 degrees. If they're both 90 degrees, what relationship do they have to each other? They're congruent. Now, I know what you're thinking. You're thinking, Miss Martin, we said they're right angles. It's not necessary to say they're congruent, but it is. We have to take it that one more step and say, oh, since we know they're right angles, that means that they're both right angles, they're congruent to each other. So, because we could say they're obtuse angles. That doesn't make them congruent, right? We could say they're both acute angles. That doesn't make them congruent. When we say they're right angles, that makes them congruent. So we say angle ADB is congruent to angle CDB. And what's our reason behind that? How do we know they're congruent? Definition of right angles. See, you should have said it, Liz. You should have said it. Definition of right angles. When you're writing words, are there times when your hand and your brain just don't cooperate and you write letters that aren't even in the words? Do you ever do that? Like, I don't know what letter that was gonna be. I switched it to an F, but it was starting out as something completely different. Okay, so we know that this angle is congruent to this angle. What else did they tell us? They said A is congruent to C, and that's given, right? So they gave us this, and they gave us that. What else do we know?
That BD is congruent.
BD is congruent to BD because they both have it, right? It doesn't change size from one triangle to the other triangle. So they both have that one. So what's our reason behind that? When they both have that thing. Reflexive property. When they both have it, it's a reflexive property. So here's what we know. We know this angle is congruent to this angle. We know this angle is congruent to this angle. And we know this side is congruent to this side. What does that tell us about them triangles? Based on what triangle congruence theorem? No. Angle, angle, side. Angle, angle, side. Angle, angle, side. I'd probably let you get by with side, angle, angle. We just don't normally say it that way. So, triangle ADB is congruent to triangle CDB. Why? Angle, angle, side. Okay? Is the bell about to ring? Yeah.